Well, good evening, everybody. And just like that, we are at the final session for day three at siberXchange 3.0, the challenge statement edition. This day was dedicated to critical infrastructure. And we've heard from some major players in the space: Trace, Juniper, and other advisory board members from Waterloo North Hydro, Electrical Services Safety Authority, so on and so forth. It's been a day when we've got to reflect on how important it is to not just be able to protect against an attack when it hits our critical infrastructure, but also recover from it. And one of the key lessons that I took from today was this idea of you're not just measured on how much you can protect, but how quickly you come back up. We also realized very quickly about the interdependencies of all of our operational technologies. In this last session, we're going to go further into a bit of a micro when it comes to critical infrastructure, trying to understand how cloud for all, can help us power better, more equitable infrastructure. Daniel, at the very opening of our opening talk show, had mentioned something extremely important. What on earth is not critical? And in this session, while we touch on the technical aspects of how do we make cloud more equitable, we'll look at the social ramifications, the political, economic ramifications of making cloud equitable and making cloud more accessible. A mentor of mine once says that open source technology or open technology is at the foundation of cloud computing. How can we make cloud more open and more equitable for all? My name is Abbas Hirji, leading both the AI Hub and the Center for Cybersecurity Innovation at Durham College. I want to thank all our audience members for joining in. I also want to thank all of our panelists for joining in, not just from across Canada, but from across North America, in fact, across the world. Before I begin, it is extremely important that I also recognize that this conference is coming to you from Indigenous lands, but more importantly, even the virtual digital space constitutes Indigenous space. Our Wi-Fi networks, our 5G networks, our land-based networks all run across this land. As an Indigenous elder once said, in nature there are no owners. I welcome and thank our Indigenous cultural community for giving us this opportunity to share in our knowledge and in our experience. Let's jump into the topic for today. And before I introduce the main individual who's going to be answering the challenge statement, I'm first going to reintroduce one of our advisory members, Ketan Kapadia from BlokSec Technologies. Ketan, welcome. Thank you for taking the time. More importantly, why is this conversation on cloud equity extremely important, and why is it very challenging to achieve? Ketan, the floor is yours.
Thanks, Ali. Again, it's a very interesting topic, right? Because I think at the end of the day, if you look at where we were 10, 15 years ago, where everything was more on premise to now we're moving everything from a SaaS model perspective. I think it's critical to see how can these infrastructure type capabilities can be made easily available and accessible to sort of the core masses out there, right? And I think, and even going back to my days when I worked for large organizations and used to have these big, massive servers, computing power, and stuff like that, right? You really needed some serious horsepower and money to accommodate that type of infrastructure. But now I can go to one of the cloud service providers, give them $5-10, get some computing hours, and sort of get the ball rolling at a high level, right? But I think really it is kind of important that even though these things are easily accessible, I think trying to ensure that it is used appropriately and effectively is key. But then there's also the other aspect of it which is the security aspect of things, which also need to sort of go hand in hand. Just because cloud is available, great, but then what about these security implications now, right? Because every day, every other day, we see security challenges where an S3 bucket was left open and a lot of data was compromised or malicious actors were able to walk away with things, right? So I think when we kind of look at cloud in general, we kind of want to ensure that we look at it holistically as to how it's accessed, but then there's the other side of it from an education perspective, from a security perspective, to ensure that we all kind of work together to make sure that we make cloud much better, easily accessible, but also, security enabled to sort of really make it fruitful for everybody from a consumption perspective.
No, thank you, Ketan, for reminding us about the security frameworks and canvassing this conversation within security. And I would agree with you once again is that for the audience that's watching, in the little ticker below, you'll be seeing some data points that are flying off over there. And you'll see two very important stats. Number one, about 83% of workload within OT technologies, especially in critical infrastructure, has moved to the cloud. And between, I think it was January to April of 2020 as well as 2021, number of attacks have increased about 8 to 10 times over when it comes to across cloud environments. So not only are we talking about making access to cloud more equitable, how do you also make security more equitable in that process? And now with that fantastic introduction, I'm going to introduce you to an individual who probably has this is his first session on the siberXchange platform. He's one individual who I've got to know and has been a huge supporter along with his firm off Durham College and my students and my team. An individual who reminds you that intelligence is not about knowledge, but creativity. With what this gentleman is doing at Arc Compute, there's a lot of creativity to addressing equity in the cloud that I'm looking forward to challenging him on. Arthur, welcome to siberXchange 3.0. In your own words, tell us a little bit about what Arc Compute does, your own background, and in your perspective, what do you mean when you say cloud equity? Arthur, the floor is yours.
Thanks so much, Ali. Yeah, I've got to learn to give introductions as good as yours. So Arc Computes, just to answer your question, we started out a couple of years ago. Largely at the time, it was because sort of my co-founder and I, we were dealing with, I think, DigitalOcean at the time. We had a $5 a month instance. That was very sort of middle of the road. And then as time went on, we found that a lot of the things that we wanted to do in the cloud actually didn't just use the CPU. They were starting to use things around the GPU. And I think as the last couple of years have gone forward, you've seen that more and more of the workloads that people are doing in the cloud are starting to move to the GPU. And what we found was when we went over to Amazon, we were paying, a lot more than $5 a month. We were paying something like $19,910 a month. And we couldn't reconcile where the differential in price came from because, they're both basically just, you take some sand, right, silicon, and you fabricate it into some chip, and then it runs some stuff. So why does one $20,000? Why is one $5? And in asking that question, it sort of led us down a path of developing software that essentially was aimed at trying to address this issue of inequity, which is that large corporations and groups of people with venture funding are able to afford this sort of silicon that the real workloads of today actually run on. And people who are these little startups, people without lots of money, they're left essentially with the scraps. So that's the stuff that you would get out of DigitalOcean or any of these other platforms, which really only give you sort of the bare metal minimum of CPU. So what we're essentially trying to do is we're trying to create a sustainable future for modern workloads in cloud environments today. And that's to say that if you're doing anything interesting, it's using the GPU. And we believe today what we have is the most aggressive price performance in the world in GPU cloud compute.
Very bold statement indeed, but I would agree with you that you often have this misnomer that we've got everybody at the digital table and that constitutes equity. But once they're at the digital table, how much voice do they have? How much access do they have? And I think, Arthur, you're pointing at some very, very interesting policy-related questions, which will probably come up as we go through the next 40 minutes of our discussion. So, Arthur, I'm going to jump right into this. And first, I'll set some context with Ketan on the security side of things. Now, Ketan, you've got an extremely profound background when it comes to access and management. Can you help our audience understand that when you have a cloud computing cluster, when you have access to some cloud and you start to provision root access and access to different members of your team, what are one or two top challenges that come up when it comes with access management and the cloud? Ketan, I'll give you the floor to set some context.
Yeah, no, and that's great. So I think it's like any other platform, right? And I think I just take when we kind of look at cloud in general, right? Like from a identity and access management perspective, you can get to the granular level of what a person can do within the context of that cloud configuration, and you can even define things at the role level, right? So you basically have this huge spectrum of how do you give access and controls at the right level and at the right time for those individuals, right? So any organization taking on sort of the cloud security aspect, you kind of need to ensure that you understand what's happening. You have resources with the right knowledge and the skill set to help drive things from a security perspective, right? So I think cloud becomes more critical from a security perspective, because those perimeters that you had before, where John has to actually walk into a server room, log on to a server, those days are gone now, right? I can access a console. If I have the credentials, I can log in. And if I can log in with a compromised credential and other things, then I'm inherently getting full access with someone who has got access within the cloud configuration to do whatever they want to do, right? So I think it's becoming more and more critical that when it comes to access control, organizations need to put more focus around it. And then also the other element to that is, how are you configure things within the context of cloud, right? So because obviously back in the traditional days, you had networking people who would go and configure your firewalls and who would go and configure switches and stuff. Within the concept of cloud, all of that is almost like a closed environment now, right? So with the right permission, I can go and create a bunch of virtual networks, go and create a bunch of VPCs and configuration. So with the right access, I can now pretty much do anything within the context of that cloud configuration. So it's becoming more critical to ensure that when you look at this holistic view from a cloud perspective, and then tying it back to access management is critical, but also ensuring that as you start configuring the underlying elements, you understand the security impacts of which configuration options turn on what capabilities and the level of exposure, right? So I think the cloud undertaking, I would say, is, requires additional proper validation, proper architecture, and design. And so that's why opening the cloud and making it accessible to everybody is key, important, as Arthur was saying. But then you also need to look at the other aspect of, how do we ensure the right controls are in place to help drive the effectiveness. And this way, if I'm a newbie to the cloud and if I'm just getting started, I don't want to be compromised sometime down the road as a potential startup who's just trying to get the feet off the ground.
Absolutely. And I think, Ketan, more importantly, in everything that you've articulated, it comes down to a fundamental question around equity, and that would be cost. All of these processes and provisioning this kind of a IAM environment ultimately comes down to cost. And Arthur, I'm going to bring you onto the hot seat right now and bring up, a couple of the challenge statement questions, starting with this question around how you've gone about provisioning access. And my own experience, and I can speak to this as a client of our Compute, you've got a dedicated support team. It's an individual one-to-one conversation that you maintain. How have you gone about reducing the cost to implement pretty complex identity and access management protocols? And how have you addressed some of the concerns that, say, users that are doing IP-related work in your environments would have when it comes to access? Arthur, over to you.
Yeah, so thanks for that, Ali. That's actually an excellent question. And I'll address that based in several parts. So the first thing I think we should address is this idea around how exactly you can segment access from zone A and zone B effectively without allowing people to talk across those zones, especially when you're talking about a cloud environment where you could have companies that are potentially adversarial sharing a physical virtualization appliance. So one of the great examples of this you could say is, Coca-Cola is on virtual machine 1 and Pepsi is on virtual machine 2. Well, you don't necessarily want them talking across these two appliances, despite that they happen to reside on one physical device. So the way you would generally go about that would be trying to create a hardware address separated space. So you would have a guest physical address that would be assigned to Coca-Cola. You have a guest physical address that would be assigned to Pepsi. But that would exist within the context of a host physical address. So that would be global address space. And one of the things that you will often find if you're dealing with, let's say, consumer virtualization is you see things like VirtualBox, or you see sort of hobby virtual machine software that basically does this with software. That is, I would say, one of the worst mistakes that you could make in any security context. Because what you're allowing is essentially a program on your computer to control who has access to what. What you really want to do is you want to control that with hardware. So you want a piece of your machine to physically control access to which piece of software gets access to what piece of memory. So what we've done is we've created something around IOMMU, so it's an input-output memory management unit that allows us to control where a user speaks to, let's say, a certain address. And we've had to extend those capabilities, particularly around the auxiliary devices, so devices like GPUs, things that are actually segmented away from the normal sort of address space of memory. So rather than having CPU and RAM interface directly and then creating a compartment on which you run virtual machine A, and then you have another compartment with virtual machine B, we're actually applying those same principles to the GPU. And that's really where our price performance comes in. So it's about maintaining security, of course, where we want to have zone A and zone B in the context of traditional virtualization, but we also want to apply that exact same thinking to peripheral devices like GPUs. And one of the best examples of that I'll point out, and I'll close on this, is this example recently of, I think it was Microsoft. They did something with Remote FX, vGPU. This is a part of Hyper-V. This is a common virtualization component. And it was allowing sharing of GPUs across virtual machines, but it had no form of access segmentation whatsoever. So you would have tenants who were in, let's say, for example, Azure, or that were using any kind of Hyper-V based system. And because there was no access segmentation, at least in the GPU, they could have the access segmentation in the RAM, and you would see that they wouldn't be able to talk to one another, but they could use the GPU as a backdoor into the other virtual machine because there was no form of segmentation on that device. What our compute is able to do is we're able to maintain that segmentation on peripheral devices so that even if we're sharing those components amongst virtual machines, you still have the security of the hardware managing access directly.
You know what, Arthur? Everything that you just said reminded me of something that I heard at a conference, I think at CISO Forum 2019, where the speaker had mentioned that cloud computing is not about where you do computing, it's about how you do it. And I think these aspects that you mentioned also dovetail very neatly into a conversation earlier today with Darktrace when, and I know it's slightly unrelated, but a parallel conversation around once Darktrace was implementing their solutions, a lot of folks were surprised to see what was actually happening on the network in terms of what devices connected. I think this note of what's actually consuming your resources, how you actually get billed and for what jobs, not only a security matter, but it's also from a financial matter and an administrative matter. Knowing what you're paying for is extremely, extremely important. So again, as always, Arthur, very well put together. You've addressed this aspect of the financials behind this and how you've got it to work. And as a consumer of our compute services, I can say that you've even brought a lot of cost effectiveness to your solution. I do invite our audience, I see about 100 odd that are online right now. When you are looking up our compute, go onto their LinkedIn and you'll see a comparison chart that they've provided in terms of the costs per second of consumption. And I can say that this is definitely shaking ground on a lot of generic offerings that are out there in the market. So good on you there. Ketan, I'll bring you back into the conversation and set context again with another challenging approach. Ketan, in your work, you've worked at pretty impressive enterprise. You've had a lot of engaging involvements, have some very successful exits as well. Right now, you've been focusing a lot through BlokSec, not only working with Durham College, but working with companies like Ground Level Insights, ShiftLink, so on and so forth. You've been trying to help a lot of startups and small businesses consume better identity access management services when they're working on things on the cloud, like a web application and so forth. What's the education process been like? Because it's not easy going to the CEO of a firm, a startup especially, that knows the business really, really well and is profitable. Going to them and talking to them about cloud security and educating them is by no means easy. And even if it's simple, the simple is always very complicated. How have you tried to translate that knowledge for the community? How have you got teams with lesser resources to appreciate the value of identity access? Ketan?
And that's a great question, right? And I think I always put it this way, right? Like I think every conversation for me is me trying to understand what they're trying to do, but also trying to portray something that kind of makes sense from them from a business perspective, right? So I think you kind of made an earlier comment around how this is all tied back together, right? And again, a lot of this sort of ties back to, the cost aspect of things, right? Because I think for any business owner at the end of the day, if I'm going to consume some service, whether it be cloud, whether it be processing or whatever, what is that cost to me? And then really, if I'm going to take on this additional cost of services, what are the benefits that I get out of it, right? So I think really putting in the context of at least helping them understand that if you do things the traditional way, this is what your world is going to look like. But now if you move to this new world, these are obviously your cost savings is an element, key element, but also part of that as to how this is going to help shape the future in enabling you as an organization to be more effective, more efficient, and also help drive things more from a security perspective, right? So I think really, it's kind of a two-way conversation, and obviously a bit of education for myself trying to understand what they're trying to do, but also an education from me to them as to why something like this is important. And as they start connecting the dots, these conversations become a little bit easier, right?
And I want to just take that a little bit further and bring Arthur back into the hot seat. And as always, Ketan, I think you've always focused on not just the return on investment when it comes to security, but also ROI stands for the return on imagination. And you've allowed them, and the return on innovation, and you've allowed them to see what the overall costs can be and what the returns can be if they invest a little bit of that time from a security posture. So I do appreciate your perspective. Arthur, bringing you back in here now. When you are dealing with a lot of folks who are getting into cloud, they know what they want to do. They want to access some of the the GPUs that you have. They want to access the high performance computing that you have. But from an equity perspective, sometimes, especially folks who are not necessarily technically inclined, but have the content and have the material to sell, they may not necessarily understand even the billing process, the billing cycles that. One of the things that you've done extremely well is help them understand what the cost cycles are from a computing perspective. How has that education been challenging, and how has that sort of realized itself over the last little while? Arthur?
Yeah, so that's actually another really good question. And the reason I say that is because a lot of people that I've seen, discussing things online, they've talked about how they don't even understand how their Amazon bill is structured. So what I mean by that is that you see one number when you go to Amazon, and then when you actually look at your bill, you see a completely different number. And those numbers are often, 3 times, 4 times, sometimes 10 times the amounts that you would see on that initial figure. It's because there's all these additional things that they're charging you for. So egress fees, the amount of compute that you actually use, the uptime is another aspect of it. So it's even the case that when people are creating accounts, they don't realize that if they don't even turn on their virtual machines, it's often the case that they'll be billed anyway. So what we've done to simplify that process, and we're trying to essentially resolve these pain points, is to charge a flat fee. So at this point in time, we're not telling our customers, you're going to pay $4.99 a month and charging them, $2,000 at the end of the month's billing cycle. We're charging them $4.99 at the end of the billing cycle. And the reason we're able to accomplish this is essentially because the licensing costs that we would normally be dealing with as a provider of these sorts of services don't exist for us. And that's what generally makes us unique. That's to say that the majority of these cloud providers, like for example, AWS, or even for example, Azure, they deal with licensing. So even in the case of Microsoft, where licensing is not as much of a concern because they have their own hypervisor, so the software that creates the virtual machines, they still have to pay NVIDIA for the privilege of using their own GPUs. They have to pay essentially fees to split the GPU amongst the virtual machine. That's NVIDIA Grid. And that's thousands and thousands of dollars to the provider every month. So what we've done is we've rewritten all that software. And by rewriting that software ourselves from scratch and implementing it in our own hypervisor, we've managed to get all of the licensing costs out of the equation, which makes our billing process extremely easy for our customers. Our costs don't go up with the number of virtual machines that get created as they would with Grid, so we don't charge you more. So we keep it simple. We make it easy for people to understand what they're paying for. And at the end of the day, by solving the pain points that I think a lot of people are experiencing with cloud, my hope is that some people will recognize that there are some ways that you could do this better, and perhaps the market will follow suit.
I think it's also important for our audience to recognize that, when we're talking about startups, we're talking about small businesses, especially small businesses that have been hurting as a result of the pandemic. Your team too is in a startup-like environment. It is at that phase. And you know, that quintessential question that most startup founders find themselves in: do I buy some cloud technology? Do I build it on myself? You've gone down the path of, I'm not even bothered about buying it or building it. I'm simply going to break what currently exists and then take it from there. That philosophy takes a lot of guts, and more importantly, it takes a lot of technical acumen and talent. Speaking about talent in the cloud and keeping in line with this conversation on education, Ketan, this is a question that's come in. I'll ask it to you, and then we'll rephrase it a little bit for Captain Arthur there. Ketan, from a talent and a training perspective, especially when it comes to high performance computing, these are very, very specialized skills. However, and I'm going to reword this question just a bit, we are seeing, for example, on GitHub recently, AI coming in to fill out your code. We are seeing a lot of things going through automation. How can we make cloud technical skills more accessible and equitable, especially for folks who don't necessarily have that quote unquote, although I disagree with this term, technical? Ketan?
No, and I think that's a great question, right? And I think a lot of this sort of goes back to, I always put it this way, right? Like if you want your end users or your organizations to start leveraging functionalities of your capability or cloud services, then you need to make things easy for them, right? So part of that goes back to how can you ensure easy, quick enablement? How can I understand your technology? How can I enable the end user to effectively use the technology, right? I think a lot of this sort of goes back into how can you make it end user friendly. And again, it's not only about the technology aspect, right? Yes, you are going to have techies, you are going to have people who are very technology savvy, and they'll be able to get around things, which is great. But not everybody comes from that background. So how do you ensure that? Again, it goes back to how are you sourcing that information to the right audience? And so in this way, they understand what you're trying to do and kind of how they can adopt things from a cloud perspective. And obviously training, part of that is trying to make training easy, accessible, right? And I know a lot of the cloud providers, not to put any names out there, but a lot of them, do have a lot of online courses, capabilities where you basically can, do self-learnings, and things. And I think a lot of people are taking advantage of that. And I think that's kind of where I kind of see where it'd be kind of nice to see not only the technical aspect of it, but also enable functionality where non-techies, people in the sort of the typical business function, can at least understand how I can use certain aspects from a computing perspective. How can I leverage the AI capabilities, right? So yes, there's a technical component to it, but then how can I take that AI capabilities to help me drive things from a business perspective, which may not necessarily be anything technical related, right? So I think it's just kind of finding that right balance, and obviously boils back down to training and the ability to provide that effective training at a much lesser cost, right? Because I don't want users to go and sign up for courses that cost $6, $7, $8, $10,000. Where again, it boils back down to the how do you ensure that everybody has access to these key things, so in this way they can accelerate from a growth perspective.
Fantastic. And you know what? I think you and I had spoken about this during our Tech Talk DC session on going passwordless, right? Got to get people to see the art of the possible. As a mentor of mine once said, innovation is the calling card of the future. And you've got to have the ability to show people what they could be opened up to should they grasp certain skill sets. And I think making the cloud more equitable has a huge component when it comes to getting the language around the cloud more accessible for people to understand what does it mean when you run a job in a cloud environment. Once we make that more accessible, more understandable, or in the skills of knowledge mobilization, you can translate that better, people can make more informed decisions. I really appreciate once again your perspective. This has been the beauty of the challenge statement edition. It hasn't been about selling or telling and selling, as one partner put it. It's been about a conversation. And I really appreciate the fact that you're bringing more people to the conversation around cloud. Now, Arthur, we've got another 15 more minutes. And there are a few questions. It wouldn't be a session with me if I went off script, so I have to go off script and take in these two questions that have come in. First question is around trust. And I'll reword this question just a little bit. The question reads that when it comes to using other big vendors, and you all know the names, yes, the costs may be a little bit here and there are ways to understand that cost better. But the other problem is that we do have an issue when it comes to not just costs, but it comes to trust. When it comes to a firm like our Compute, a smaller firm, and I say that with all due respect, how are you able to ensure that from a computational perspective, you have the trust of the end? Arthur?
Sorry, could you repeat that last part? I think I lost you slightly on the feed there.
Not a problem. I will just do a quick check-in right now. Can you hear me okay right now?
Yep, all good.
Fantastic.
So I can try to address the question. I think you said something around how can we be sure that our compute is trustworthy? How can we be sure that a small provider is trustworthy, or that any provider in general is trustworthy? So that's actually a really excellent question, because I think that that as an idea in computing is an issue that's generally not solved. So that's to say that, you know, if you're using any kind of proprietary software, how do you even know that it's doing what it claims that it's doing? You can't see the source code. You don't know what it's doing under the hood. How do you know that the hardware that you're executing your software on is actually doing what it claims to be doing? So this is a great example. I have this book here. This is from a gentleman named Andrew S. Tannenbaum. He was sort of the predecessor, the guy who came up with the system prior to Linux, that's Minix. I believe he also was a professor who had some involvement with Linus Torvalds before he brought Linux to the world. And this gentleman, he has some software that he wrote that's been essentially integrated into, there's a subsystem in every Intel chip called the Intel Management Engine. And it has its own ability to sort of execute software on your computer. It has its own networking stack. It has access and visibility into most aspects of the system. But, you know, people don't really know what it's doing. The source code of it is very closed. So it's raised questions around, is the hardware even trustworthy to begin with? So with all these kinds of issues of trust up in the air, I think the best possible scenario that you can look at is trying to verify what you're doing cryptographically. So if you're in an environment that could potentially be hostile towards you, your best defense against any kind of issue with an adversary is to not trust, but to verify. And what you do is you do that cryptographically. So if I'm in an environment like, let's say, AWS, and I'm concerned that the provider might be abusing me, or in some way maybe looking into my disk, trying to find certain information, the best scenario that you can have is a scenario where what the provider sees on the actual physical medium that you're using is something that is just ones and zeros. It's a big nonsensical blob to them. And you use strong cryptography to do that. So in my, actually, every time I'm speaking with a customer that I have, emails or have Zoom calls, one of the first things that I tell them is that we don't care what you're doing as long as it's not illegal. So we encourage them to go and we use, cryptography on disk. We have one customer actually that they've been doing some work with, I think it's Disney. And in their contracts, they have a clause that says working with a provider, like for example, a cloud firm, they may not see the content of your disk because they don't want, I guess, their movies leaking ahead of time. So as far as they're concerned, all their resources that are within our system, we don't have any visibility into. And the way that we ensure trust in terms of if we're going to be here in, let's say, 6 months or 12 months or any time past that, we have an initiative we're calling Open Arc Compute, which is that we have the ability, much like many other providers, to go in and to download your data. We don't make any attempt at all to lock our customers into the system. We allow them to go in to download their whole virtual machine, to download their whole disk images, so that if they want to, they can run them locally, they can run them in other providers, or they could come to us where they're going to enjoy better price performance. So in giving that interoperability, the bet is that where you're going to have more performance per dollar, you're going to choose to stay.
I'm reminded, right, of that statement where it says trust is not demanded, but it's earned, and it's earned over a period of time. And I really think that over a period of time, as you start to grow and scale your services, that trust factor will definitely be put to the test, and how you respond to that is really going to determine the future of how far some of your data centers and environments scale, and how far you're able to make cloud more and more equitable. We've got another 8 minutes or so, and there are 2 more questions that I'm going to run through. One, I know it's directed to Arthur a bit, but I think I'm going to bring Ketan first into it, and then Arthur will come to you and then have a closing question with you as well. And this has to do, it's less sort of to do specifically with cloud, but more on the security side, but I think I'm going to let this one through my defenses for this time around. So Ketan, and this is a question around the barriers of entry, smaller players in the security and cloud space. Now, you have a brand name behind you as an individual, Ketan, you and a couple of your team members. You've been in multiple large firms. But when you come in as a smaller firm with a security idea, especially if it's a security idea that you want to sell to large enterprise environment like a power services or utility grid, or whatever have you, what are some of the barriers of entry in an organization like yours? Ketan?
It's a great question, and I think a lot of it really boils down to credibility, right? It's really around what you've done, what your experience brings, and how you help your experience pass through those barriers, right? And I think that to me, that's kind of the key thing, right? So if you look at if you look at Arthur and his partner, what they've done, they were working on something, they found an opportunity, and again, help sort of, come across those barriers, and through their credibility of understanding the problem and driving that, we really help them accelerate, right? So really, I think some of this sort of boils back down to credibility is one aspect, but then the other aspect is sort of the knowledge element to it, right? Is to, do you understand the domain? Do you understand the elements and concepts of what's happening, right? Often one thing that I've come across in my career is where founders do tend to start up a company where they may have little to, not a whole lot of experience in that field, and usually it becomes more of a barrier, but also credibility becomes of a challenge too, right? So I think really, to me, it really sort of boils down to be good. If you're good at doing something, then kind of use that to your advantage. And then, and obviously every day is going to be a learning day, and you have to educate yourself more as this world becomes more complicated and complex. And as we adopt more and more capabilities from an online perspective, from a computing perspective, things are changing on a day-to-day basis. Educate yourself, because every day you'll be surprised at things you will learn, every day, which you didn't know about today.
Absolutely. And they don't say it without reason, right? That the cloud is the third wave of the digital revolution, and we're going to see multiple waves. And I know, speaking of waves, we do not want to see another wave of something which I will not mention, but we will move beyond the metaphor of waves and go to the final question and then come to some closing remarks. Arthur, you've done a great job of explaining how you've approached cloud, and we can definitely have more conversation. The final question also relates to something we discussed behind the scenes, but also relates to a question that's come in direct message, and that has to do with the monopoly around cloud. I know this may not tie into security per se, but could you shed some light on why GPU environments are extremely expensive? And without revealing too much of the secret sauce, how have you been able to, for lack of a better word, democratize and make GPUs more accessible?
Yeah, I think that's your best question yet. And that's one that I bring up or I say that because it's a question that's not asked, I think nearly often enough. So the major issue behind that is that if I want to today create, any kind of environment at all for myself, and using a GPU. So for example, if I wanted to just build a computer with a GPU in it, if anybody's been following the prices of GPUs, some of the time you can see they're $5,000, $6,000. I've seen them go up to $10,000, on eBay, people scalping them. And that's largely because of people like cryptocurrency miners and people that are using the GPU for things like TensorFlow and other AI frameworks. And the problem with that is that, the G in GPU used to mean graphics, right? But it turns out that architecture was very useful for some things that have nothing to do with graphics. And with the entrance of all these additional people trying to use the GPU, you saw a huge inflation take place. So obviously for the price of the hardware. And vendors like NVIDIA, who have been somewhat predatory, have looked at that opportunity as a way to essentially take people who would otherwise be purchasing those devices, and in the context of cloud where they're renting, they're looking at that as a way to extract additional value from them. So a way where you can go and find, okay, here's this person who's going to share this device, amongst, let's say, 6 people. So that person who's offering that device for sharing purposes, I'm going to charge them several $1,000s a month just to allow them to do the sharing functionality. And the bet is on NVIDIA's part that the individuals sharing that VM will be paying so much to that person who's offering that sharing function that the price essentially makes no difference because they have the licensing cost increase. So they would be willing to pay for the extra amount because of all the value that you can generate from a GPU. So what we have essentially done is to look at that as a problem of inequity. So some people who are doing things in DigitalOcean, they get very accessible sort of resources, things that are affordable for startups, and other people, sort of the people who are the haves, so versus the have-nots. Those people have tens of thousands of dollars a month to burn on GPU, and those are the people that end up paying Google Cloud, Azure, and Amazon. And the unfortunate thing about this is because that licensing cost every single month is so enormous, not only does it make it inaccessible for the end user to get access to, it also makes it so that the cloud provider actually has an enormous amount of cost just to start up a business. So they're paying for both the hardware upfront and they're paying for a lot of these licensing costs. And until such time as you actually have customers to support you, it ends up that the startup cost in that space is millions of dollars every year, or millions of dollars just to start a business. So by getting the licensing cost out of the equation to begin with, the hope is that we can both offer some innovative products around pricing the GPU, and we can also obviously use that extra capital that we would otherwise spend on licensing to bolster our infrastructure and to offer better products.
Absolutely, and I do invite our audience to take a look at a recent press statement that was our Compute as well in terms of their first raise and the approach that they've taken. And I think when you look at the individuals that are involved in that, you'll begin to realize that individuals who typically perhaps would not know too much about cloud architecture are starting to take an interest. I think what's key to this, Arthur, in your mission is building community around your services. Thank you for that, for a very clear response. We have 3 minutes left. I wanted to close, but we do have one question. I'm going to ask you each to give me a 30-second response. Ketan, we'll start with you. At the root of cloud is, from a security perspective, is the idea that there is some sort of redundancy in place, some sort of diversity in place. Smaller providers of cloud compute actually efficiently and securely provide that kind of redundancy. Ketan, first you for 30 seconds and closing to Arthur.
So at a high level, the answer is yes, but there's a lot of caveats to that, right? So really, it really boils down to what is the notion of redundancy that you need to operate your services or your business, right? And I think a lot of that sort of, again, will bubble up to the cost aspect, right? Because if people who are using cloud services out there know that depending on how much backup and redundancy do you need, you have to fork out some serious dollars to make some of those things work, right? So I think really what it really boils down to is that you need to understand what's critical for you, and then you need to pick and choose what makes sense for you.
Great response. Arthur, closing statement to you on that question.
Yeah, so that's another good question. And one of the interesting things about that is it actually ties in with the previous, which is that if you look at, for example, Citrix, one of the major providers of virtualization software, one of the major features that they offer in their paid version, the enterprise version being used by many clouds, sort of this license thing that they sell every year, that version has automated backups built in. And that's one of those things that you would actually see reflected on the price every single time you create a virtual machine. So you'd see that the licensing cost gets built in because of the automatic replication features that are offered through something like Citrix XenServer. With Arc's hypervisor, we're calling it libarcd. That hypervisor, it actually incorporates automated backup. So for example, if you have a RAID, so a redundant array of inexpensive disks, that's I think the acronym. In that scenario, a physical disk can fail. You can have it spin out or have it, the platter can rust or something like that and break. But because the array is redundant, you can pop out a drive, plug in a new one, hit the rebuild button, and then essentially the entire array goes along without shutting down. So because infrastructure like that can essentially keep your machines up, to the point where it's 9.9999999, right? So the incredible nines, the length of uptime is what I mean to say. You can do things like that in hardware that prevent your system from going down, even if physical disks fail.
I'd agree. And I think this aspect of redundancy, there's geographical diversity that comes into the picture, but there are ways to ensure that locally itself you can have multiple paths of redundancy. And it comes down to what I had said and introduced Arthur with in this session, which intelligence is not about knowledge, but about creativity. And thank you, Arthur, for closing with a statement to the challenge from a creative perspective. Gentlemen, Ketan and Arthur, thank you so much for your time today. I'm going to ask you to stay on while I bid the audience adieu so that we can have a quick 30-second debrief once we line. But once again, thank you for joining us. That was phenomenal, very interesting. I think from from a business standpoint, not only have we been talking about the security of business, but today we also started talking about the business of security itself. I think the two of you have brought some interesting topics that I'm sure the team at CyberX will be reflecting on, as well as the advisors, and looking at sessions. Security of business as well as the business. For our audience, this brings us to the day of siberXchange 3.0. Day 3 brings us to the end. Tomorrow at 10 a.m. EST, we will be kicking off siberXchange 3.0 Day 4, where we begin the discussions on healthcare. I am your host for the opening talk show. I'll see you then, but I'll also see you at the closing session where I'll be interviewing the Privacy Commissioner Officer of Alberta, Clayton, and I'm looking forward to seeing you all at that time. There's one thing that I learned today is that we should not be taking the cloud for granted, not assuming that it's always going to be there. Right now, and I say this by reflecting on some of the words and the bold statements that Arthur has made, and he has been very bold about it, and all the power to him, where he mentions about predatory practices around the cloud, especially around access. Now, right now in this pandemic, we've all been afforded different coupons, different credits, so on and so forth, and things seem to be working well. Shouldn't take that for granted because those will eventually run out. Yes, you may not be experiencing any issues right now, and all things may look hunky-dory in terms of your applications from a digital standpoint. Cloud. When it comes to security, there is absolutely no complacent. Noah didn't build the ark when it was raining. Don't start being complacent about the cloud now, simply because. Safe day and night. Wherever you're joining us, I'll see you tomorrow, 10 a.m. EST. Take care, and thank you again for joining us at siberXchange 3.0.
Thanks so much, Ali.